General good morning to everyone. I am dedicated Akshitha representing TSW or FPDC Degree College for Women. Now I am discussing about the topic on optical fiber in physics. An optical fiber is a flexible fiber, transparent fiber made by the drawing glass or plastic to a diameter slightly thicker than that of a human hair. Optical fibers are used most often as a means to transmit light between the two ends of the fiber and find wide usage in fiber optic communications where they permit transmission over longer distances and at a higher bandwidth than electrical cables. Fibers are used instead of metal wires because signals travel along with them with less loss. In addition, fibers are immune to electromagnetic interference, a problem from which metal wires suffer. Fibers are also used for illumination and imaging and are often wrapped in the bundles, so they may be used to carry light into or images out of the confined spaces, as in the case of a fiber scope. Specially designed fibers are also used for a variety of other applications, some of them being fiber optic sensors and fiber lasers. Fiber optics typically include a core surrounded by a transparent cladding material with a lower index of refraction. Light is kept in the core by the phenomena of total internal reflection, which causes the fiber to act as a waveguide. Fiber that supports many propagation paths or transverse modes are called multimode fibers, while those that support a single mode are called single mode fibers. Multimode fibers generally have a wider core diameter and are used for short distance communication links and for applications where high power must be transmitted. Single mode fibers are used for most communication links longer than 1000 meters. Being able to join optical fiber with low loss is important in fiber optic communication. This is more complex than joining electrical wire or cable and involves careful cleaving of the fibers, precise alignment of the fiber cores and the coupling of these aligned cores. For applications that demand a permanent connection, a fusion splice in common. In this technique, an electric arc is used to melt the ends of the fiber together. Another common technique is a mechanical splice, where the ends of the fibers are held in contact by the mechanical force. Temporary or semi-permanent connections are made by the means of specialized optical fiber connectors. The field of applied science and engineering concerned with the design of application of optical fibers is known as fiber optics. The term was coined by Indian-American physicist Narendra Singh Kapani, who is widely acknowledged as the father of fiber optics. An optical fiber is a cylindrical dielectric waveguide that transmits light along its axis by the process of total internal reflection. The fiber consists of a core surrounded by a cladding layer, both of which are made of dielectric materials. To confine the optical fiber in the core, the refractive index of the core must be greater than that of a cladding. The boundary between the core and the cladding may either be abrupt in step index fiber or gradual in graded index fiber. When light traveling in an optically dense medium hits a boundary at a steep angle larger than that of a critical angle for the boundary, the light is completely reflected. This is called total internal reflection. This effect is used in optical fibers to confine light in the core. Light travels through the fiber core bouncing back and forth of the boundary between the core and cladding because the light must be strike the boundary with an angle greater than that of a critical angle. Only light that enters the fiber within a certain range of angles can travel down the fiber without leaking it. This range of angle is called as acceptance cone of the fiber. The size of this acceptance cone is a function of the refractive index difference between the fiber's core and cladding. In simpler terms, there is a maximum angle from the fiber axis at which light may enter the fiber so that it will propagate or travel in the core of the fiber. The sign of this maximum angle is the numerical aperture of the fiber. Fiber with a larger Na requires less precision to splice and work with than fiber with a smaller Na. Single mode of fiber has a small Na. Optical fiber is used as a medium for telecommunication and computer networking because it is flexible can be bundled as a cables. It is especially advantageous for long distance communications because infrared light propagates through the fiber with much lower attention compared to the electrical cables. This allows long distances to be spanned with few repeaters. Thank you and Jai Hind.